machine. We can see everywhere in supermarkets or convenience store, but who knows the application of this machine and how to induce the codes? First, the light emitting diodes will shut a bunch of red light in order to scan the barcode. And then the CCD will get different information from black and white strips of barcode. And then it will turn the barcode into different information. And that's the reason why there is always a bunch of red light in the front of barcode machine. And that is how it induces the code. Thank you.
Welcome to RFID and the barcode machine. RFID means radio frequency identification. It is a wireless communication technology. It doesn't need any machinery or optical contacts, like press the button or light scanning. RFID system is consists of RFID reader and RFID tag. When it is the inside of the reader, here is a very big coil. When the current goes through the coil, it would react a magnetic field, and this is the inside of the tag. And it also have a coil and a capacitor and a IC chip. When the tag passes the reader, because of the power is low, and the change of the magnetic field, here will induce electromotive force. So when the current goes through the capacitor, it will begin to store charge. And when it has enough charge, the chip will send information back to the reader. Thank you.
Hello, my name is Liao Bingkai. I want to introduce the different frequency RFID tag. First is the low frequency tag. The low frequency tag is the most common tag in our life. Its greatest advantage is it can effectively output signal when the tag is close to metal or liquid. But it has to be read in a short distance, and it cannot read a lot of text at the same time, and it can only save a little information. Second is the high frequency tag. The main application of the high frequency is the easy card. Compared to the low frequency, its both rate is faster and can read a lot of text at the same time. Third is the ultra frequency. The ultra frequency can read text in a distance of 3 to 4 meters away, and its bounce rate is faster, and the most important thing is it costs a lower price. Therefore, it becomes the main system in the market, and it has been widely used in the management system in airlines. The other one is microwave. The characteristic and the application of the microwave are similar to ultra high frequency, but is more sensitive to environment. It is generally applied to product management. Now I'm going to introduce our experiment. This experiment is going to simulate a RFID reader. We use a function generator, an oscilloscope, and a 2 Cooper coil. First, I use the function generator. I'll put a 36 kHz sine wave to the down Cooper coil. When the coil receives the signal, it will generate a continuously alternating magnetic field. When we use the tape passed through the magnetic field, it will send back a digital signal. We use the upper Cooper coil linked to the oscilloscope to receive the signal. So we can see a signal on our oscilloscope. We can see many bumps on our oscilloscope. The higher one is signal 1 and the lower one is signal 0. The stink signal is the continuous 1 or continuous 0. This is our first experiment. Now I'm going to introduce our second experiment. This experiment is going to simulate an RFID tape. First, we use the function generator, output the signal to this coil, so it will generate a continuously alternating magnetic field. Then, we link a buzzer and the LED light on the upper coil. And then we make this unit. This is a coil linked to 3 capacitor. This is our simulating tape. So when we use the unit pass through the magnetic field, it will generate a induced current in this coil, and the capacitor will start to store the energy, and then release the energy once again by its own frequency. The phenomenon is called LC oscillation. So when the frequency equal to the buzzer and the LED light frequency, the buzzer will buzz and the LED will light up. This is our second experiment.
I will introduce barcode first. I introduce one-dimension barcode. One-dimension barcode is the most common way to reading the information of merchandise. It is composed of black and white stripes. The stripes can present the corresponding letters or numbers. Currently, EAN13 is the most common one-dimension barcode. When barcode being read, it will correspond to a database and find information from the database. Then I will introduce two-dimension barcode. Two-dimension barcode is the advanced version of one-dimension barcode on the aspect of saving. Two-dimension barcode is much bigger than one-dimension barcode. One-dimension barcode can only save 15 letters or numbers, but two-dimension barcode can save 1,100 letters or numbers, even Japanese or Korean. In reading, you just use a smartphone with 300,000 pixel camera and a decoding program. Because the information in two-dimension barcode is placed on the internet. Furthermore, there are 3 location points on the corner. So you can read the two-dimension barcode at any angle. Additionally, two-dimension barcode has greater capacity for the resistance to damage. It can be correctly read under 30% damage.